Okay. In our lab, we use poppy seeds for much of our experiments for quite a few reasons. One is previous literature we've published in the lab. A lot of it deals with the characterization of these poppy seeds as a kind of nice analog to a lot of dry granular media. Because we've shown in the past in previous publications that as long as you don't have much cohesion and you can really characterize the fundamental physics of most dry granular media that have small enough grain sizes as basically the same. Their resistive forces just scale by a scaling factor. But the fundamental physics of reaction forces as you push into a material, they're all this. All kind of these non-cohesive dry granular medias will exhibit the same kind of physics that way. As to the practical sense of why we use poppy seeds, there's three nice reasons that we always like to cite. One is that they don't produce fine particulate. A lot of our experiments involve fluidization, so we have these granular materials in beds that fluidize after an experiment to reset the terrain to a homogeneous state. And lots of sands are pretty polydispersed, so they'll have very fine small particles. After fluidization, those can get in the air and cause a respiratory upset to the experimenters. Poppy seeds are kind of irregular, but they're pretty monodisperse. They're all pretty much 1 millimeter in diameter, and they don't produce any of this fine particulate. Another reason is these poppy seeds will crush well. Regular sand made of quartz, if that gets stuck between the fine gears of your delicate robot, that can scratch it up and cause damage. However, poppy seeds are much softer in the sense that they can crush between moving surfaces quite easily. They'll just crush down to a little fine powder usually, and that won't damage your delicate robot.
All right, thank you. And we have a question online from Rick Lovett. He asks first, number one, how big is this test rover? And number two, so does sweeping involve does sweeping involve averting and inverting the wheels on the axis comparable to a human shin if I view the wheels as feet? So the first one was how big is it?
Well, that's the easy one. It's around 20 centimeters in length and about half that in its width. Sid is right now showing
There's again there.
Scale.
Yeah.
Yeah, there we go. Yeah, so here's a picture with a scale bar at the top left of about how big it is. So it's about, I would say, like 20 centimeters long, 10 centimeters tall, 10 centimeters wide. That's the approximate one for the mini rover. And sorry, could you repeat the last question, the second question?
Sure. All right, so does sweeping involve averting and inverting the wheels on the axis comparable to a human shin, in parentheses, if I view the wheels as feet?
So a lot of the I'll try to answer properly, but a lot of the sweeping action we use for our gates is along the vertical axis of the leg. As you can see in this diagram, you have these rotational arrows near the wheels. That's how the sweeping goes. It's pretty much a servo motor right along the axis of the lifting leg. So we usually sweep at angles from like 45 degrees to negative 45 degrees, or from 0 degrees to 90 degrees. And then after a sweep is finished, that leg will lift, disengage from the granular material, so it's no longer applying pressure, and reset itself. Because you usually want to lift out of the material when you're doing your reset gate so you're not pushing opposite your direction of travel. I hope that answered the question somewhat.
Okay. Any other questions in the room? I guess the last question I have is just what's next for this project for the rover?
So a lot of what's next, we believe, is characterizing the granular force response that this kind of gate creates at a more kind of individual leg level, like what we showed with the single wheel test with a force sensor. Characterizing the force response to that, kind of getting a better understanding why this seems to work so well, why it's so robust in its ability to hill climb with this kind of terraforming gate. Basically characterizing the gate cycle's force response would be the one sentence.
All right, unless there are any other questions, anything online? Okay. All right, well, thank you very much.
Thank you.
They'll be available